next step, we are still dealing with integration. So we're still doing antiderivatives. We have now talked about definite and indefinite integrals. So the indefinite, there's no limits, so you have to make sure you put what on the end? Plus c. When we have limits, then we can plug those in and we'll get a number answer. Today we're only dealing with the indefinite integrals, so all of our answers will have plus c. Tomorrow we'll be taking our approach and applying it to definite ones. But what we're doing is trying to extend what we can integrate. So we know we can do antiderivatives, but we're pretty limited. We can't do a product in reverse. We can't do a quotient in reverse. We have to simplify everything so we don't have variables being multiplied or added before we're able to do that antiderivative. But we know from doing derivatives that not every answer is that clean and pretty. And sometimes that's not an option. For instance, if I gave you x times the square root of 3x squared minus 4, is there any way to write that without x's being multiplied together? No. But we can encounter those kinds of things and still need to be able to integrate them. So that's where the substitution rule comes into play. And it's basically saying if you have a composition, if you have some ugly looking things, a function inside a function, we can substitute that inside one and get a cleaner looking thing to do the antiderivative of. Now I think the way the book spells it out is a little confusing. So I'm just going to jump in with an example and see if we can build on it from here. So this is one that we would have been able to integrate before. That 2, does that change anything at all? No, we know we could just keep that and do our antiderivative. So a substitution is not necessary here, but I'm going to use this problem to kind of illustrate how it would work. So what we do is we are going to take the inside function. So my inside is the 2x plus 1 inside that parentheses. So when I'm talking about the inside, think like inside a wrap, inside a parenthesis, inside an absolute value. You know, sometimes it might be inside a trig function or the denominator of a fraction. If you are going to plug in a number, where do you start? That's the inside of your function. And I'm going to let u equal that. Okay, so u is 2x plus 1. Now, I want to be able to take my original problem and write it without any x's whatsoever. So this would replace the 2x plus 1, but I still have a dx on the end. So what we're going to do now is the derivative. So the derivative of u would be du. What's the derivative of 2x plus 1? 2. And I'm going to put the dx over here. This is kind of like the implicit differentiation we did back before. Instead of writing it as du dx, we're just moving that dx over to the other side. And so now it might make a little more sense why I wrote the problem as I did to start with. We have the integral. 2x plus 1 is going to get switched to a u to the 5th power. And 2 dx, what is that equal to? du. So we just have to do the integral of u to the 5th du. So what is the antiderivative of u to the 5th? And what else would this mean? Okay. Now, the original problem had x, so at the end we have to sub back. So instead of u, what would I write? So that's an integral using substitution. Now, was that a lot more work than we needed to do to solve this problem? Absolutely. But there are problems that we cannot solve without this option. Let's look at one of those. So if I gave you this problem, we know we can't just go forward and do an antiderivative because I have x's being multiplied together. Is there any way I could go ahead and multiply those first to clean it up? No. So that's what tells me I have to do a substitution. What is the inside here? Right, the thing under my radical. So that inside is my u. So du is the derivative. What is the derivative of 1 plus x squared? 2x dx. So, when I go to do this antiderivative, I have a square root. 1 plus x squared is u. And then 2x dx, what's that get changed to? Is everybody okay with that substitution? So we just have the antiderivative of u to the 1/2 du. So what do we do? So if you add 1 from the power to the power, that's 3/2. So it gets a 2/3 in front. We need a plus c. And then the final answer, we have to change it back to the variable we started with. So instead of u, put 1 plus x squared to the 3/2. If you wanted to check yourself, let's say you thought you made a mistake, how could you check it? Yeah, do the derivative of that and see if you get back what we started with. Is that one okay? Alright, so this is all we're doing today. We're just going to practice these things. Some of these problems, substitution is necessary. Some of them might be able to be solved without it. Could I do this one without substitution? No, because I have x's being multiplied together. What is my u going to be? Okay, so that would take the place of all of this. Now, du. What is the derivative of x cubed plus 9? You with me, Corbin?
I am. Swear.
Okay. Were you measuring how long your hair was?
Maybe. Reese's Bangs.
Okay. So, let's look at this. My problem has an x squared and a dx. Do I need that 3? So I can't just say, oh, this turns into du because I need a 3x squared dx. What else could I do? Yeah. If you divide that 3 over, I'm just going to write it as 1/3 du. So the x squared dx, if you have a coefficient you don't need, you just move it to the other side. So we have an integral. Square root x cubed plus 9 is u. The x squared and the dx together will turn into a 1/3 d. You can write this as the integral of 1/3 u to the 1/2 d. So integrate. The 1/3 would stay. Add 1 for the power, so that's 3/2. We get a 2/3 in front. This is 2/9 u to the 3/2 plus c. And then final step. U was x cubed plus 9. So that's our final answer. All right. You guys do one more together before I have you try a couple. Is this a problem that would require substitution? No, because I only have one x here. So you could think through this without, or we could do substitution with it. Which way do you guys want to do? Okay, so let's practice our substitution. So what's my u going to be? So du would be 3 dx. Do I need both of those? No, I don't need the 3. So I'm going to divide it over or write it as a 1/3 du equals dx. So we integrate, we have the sine of u. Dx turns into 1/3 du, or you could even write the 1/3 in front of your sine if you prefer. Coefficients just stay. What's the antiderivative of sine? So this is negative 1/3 cosine u plus c. Negative 1/3 cosine 3x plus 4. Why don't you guys try 5 and 6? When you go to do the antiderivative, you cannot have some x's and some u's. Everything has to be in terms of one variable. So if you've done your substitution and you're looking at your integral and you still have a dx or an x in there, you have a problem. What did you pick for your u? So du, the derivative of that would be 2x dx. Okay, and everybody got to here fine. When I look at my problem, I have to get rid of this, this, and this. Everything with an x in it has to go away. So the 3 is fine. Cosine of x squared, that would turn into cosine of u. Then I have an x dx. I have part of that here, so I don't need the 2. So that means 1/2 du could replace the x and the dx. So I kept the 3, I changed this to cosine of u, and then x dx is going to become 1/2 du. Or if you multiply 3 times 1/2, that's 3/2 cosine u du. What is the antiderivative of cosine? Positive sign, right? Because the derivative of sine is cosine. You were thinking the derivative of cosine instead of the antiderivative. So this is 3/2 sine. Instead of u, I put x squared plus. And you could always check yourself if you did this derivative. You have to do a chain rule when we get back to where we started. What about this one? Could we do it without substitution? No, because we have multiple x's. So, what's my u? That first thing you have to do inside the parentheses. So, du, derivative of x to the 4th. And it gets a dx on u. Okay. I need the x cubed and the dx. I don't need the 4, so I divide that over. So 1/4 du equals x cubed dx. So the integral. Cosine of u x cubed dx is a 1/4 du. 1/4 cosine of u du. Antiderivative of cosine? Let's see. 1/4 sine of x to the 4th plus 2 plus c. I'm gonna try a couple more. This one, it may be less obvious what the inside function is. But keep in mind, when it says secant cubed, that means you have secant of x to the 3rd times the tangent of x dx. So what do you think the inside function would be? Yeah, that thing to a power is most likely going to be u. So u would be secant of x. What is du? What's the derivative of secant? That would get a dx. Alright, can you guys figure out how that figures in here? How would I use that? I'm just wanting to write this without the secants and tangents. Okay. We need secant x tangent x dx for my du, right? Okay, right now I have a tangent x and a dx together. So I would have to pull one of these secants over with that. So would we agree that this is the same thing as if I wrote secant of x squared times secant x tangent x dx? You agree? If you multiply this, you still get the secant cubed that we started with. So secant x, what's that get changed to? U. So that's a u squared. Then the secant x tangent x dx becomes du. Antiderivative of u squared? Let's see. 1/3 u is my secant. We get 1/3 secant cubed x plus c. I know that one was a little more challenging. I want to go ahead and try one more challenging one, and then we're going to stop here for today. Tomorrow we'll be practicing more of these with definite integrals, and we'll probably most likely have another day after that with a little more practice, depending on how we're doing. Okay. All right. Can I do this one without a u? No, because I can't multiply that out. Or I could, but I don't really want to. What would my u be? And du? Okay. I don't need the 3, so that means 1/3 du plus dx. Here's the problem. This 3x minus 1 will become my u. This dx will become my 1/3 du. What else do we have? We have another x out here. Okay, I can't do two substitutions in one problem. What could I change x to? Any ideas? We need it in terms of u. What's u? We add the 1 over, divide by 3. Okay. So it doesn't necessarily look like this has helped me, but it's going to. So this x, I'm going to replace with a u plus 1 over 3. This 3x minus 1 to the 5th is going to become u to the 5th. And my dx is 1/3 du. Alright, if I multiply this, so this would be u times u to the 5th would be u to the 6th. I could even write it as like 1/9 u to the 6th plus 1/9 u to the 5th du. So initially it didn't look like I made my problem a whole lot easier, but it did, because now my thing to a power was just a single term, so I could multiply them out. Alright, can we do the antiderivative of 1/9 u to the 6th? Yeah, so you're going to use the 7th, 1/7 in front, so 1/9 times 1/7, so 1 over 63. 1/9 u to the 5th, so that's a u to the 6th, so we have to multiply by 1/6, so 1 over 54 u to the 6th, plus c. And then final step, we don't want u's, so we replace that. U was 3x minus 1. So substitution is just a way of rewriting the problem so we can think about the antiderivative. Any questions so far? So this homework, it will be due, let's see, today is Wednesday, so it'll be due Friday. You are ready to do 3 through 39 every other odd. And then tomorrow we'll finish up and I'll give you you can do the last 7 problems. And then we'll turn it all in together.